Hello, everybody. Let's continue. Automate your builds with the make tool. So that's where we stopped at. We're going to actually stop ourselves from, let's see, let me show you. Doing this all the time, first compiling our code with the dash C into object files, and then basically then we end up linking them manually with the dash O to finally create the executable. We can actually somehow automate this process using the make tool. So let's learn about it. So yeah, automate your builds with the make tool. You can compile your applications really quickly in GCC as long as you keep track of which files have changed. That's a tricky thing to do, but it's also pretty straightforward to automate. Imagine you have a file that is generated from some other file. Let's say it's an object file that is compiled from a source file. So you take this thruster.c, and if it happens to be newer, I think the what is considered new is to be by the timestamp. You take that, you compile it to a .o file. Okay, how do you tell if the thruster.o file needs to be recompiled? You just look at the timestamps of the two files. If the thruster.o file is older than the thruster.c file, then the thruster.o file needs to be recreated. Otherwise, it's up to date. That's a pretty simple rule. And if you have a simple rule for something, then don't think about it. Automate it. That's true. There's something that's like kind of really easy to do, and it's kind of repetitive. Always seek to try to automate it if you're doing it often. Okay. So make is a tool that can run the compile command for you. The make tool will check the timestamps of the source files and the generated files, and then it will only recompile the files if things have gotten out of date. So yeah, it goes by date. Okay, cool. But before you can do all of these things, you need to tell make about your source code. It needs to know the details of which files depend on which files. And it also needs to be told exactly how you want to build the code. Okay? So you basically need to be very explicit in make with the make file. Okay? So, what does make need to know? Every file that make compiles is called a target. So every file that you use make to compile is a target. A target is a file that is involved with the whole process. Strictly speaking, make isn't limited to compiling files. A target is any file that is generated from some other files. Okay, so a target might be a zip archive that is generated from a set of files that need to be compressed. So it sounds like a target could just be any file involved in this process. For every target, so for every file, make needs to be told two things. First, the dependencies, which files the target is going to be generated from. The recipe, the set of instructions it needs to run to generate. Wait, to run the set of instructions it needs to run to generate the file. So the command, the recipe. So the dependencies are which files the target is going to be generated from. So all the files that make up the target. So the target will be, oh, okay, so the target is something that's going to be generated by make. So it's not necessarily all the files. It's, I guess I read this wrong. Every file that make compiles. So it's the result of what make produces. So whatever make produces is called the target. And the target, so it needs to be made from the dependencies of make. So make will, you need, for make to work, you need the dependencies for that target, and then the command to put all that together to make the target. So that's the recipe. Okay, makes sense. right. Together, the dependencies in the recipe form a rule. A rule tells make all it needs to know to create the target file. A rule tells make all it needs to know to create the target file. Okay, so dependencies, recipe makes up the rule. And the rule is basically all that's needed for make to create the target. So how make works. Let's say you want to compile thruster.c into some object code in thruster.o. What are the dependencies and what is the recipe? Okay, so if this is target, then dependencies is basically thruster.c. So the thruster.o file is called the target because it's the file you want to generate. Thruster.c is a dependency because it's the file the compiler will need in order to create thruster.o. So yeah, makes sense. And what will the recipe be? That's the compile command to convert thruster.c into thruster.o. Okay, so what's the recipe is what is the command that is necessary to create your target. So you have to define your target. Basically, we want to create thruster.o. The dependencies necessary to create thruster.o is thruster.c. Now, how do we do that? We need the command, which is the recipe, which is going to be gcc-c thruster.c, and that's going to generate thruster.o. Okay, makes sense. Yep. If you tell the make tool about the dependencies and the recipe, you can leave it to make to decide when it needs to recompile thruster.o. But you can go further than that. Once you build the thruster.o file, you're going to use it to create the launch program. That means the launch file it's another target, yeah? It can also be set up as a target because it's a file you want to generate. The dependency files for launch are all of the .o object files. The recipe is this command. So take all the object files, which are going to be the dependencies, to make the target launch, which is executable. And the recipe, the command to do that is gcc star.o-o launch. Got it. So once make has been given the details of all the dependencies and rules, all you have to do is tell it to create the launch file. Make will work out the details. But how do you tell make about the dependencies in the recipe? So how do we even like make this file, right? Okay. Tell make about your code with the makefile. All of the details about the targets, dependencies, and recipes need to be stored in a file, either called a makefile with a lowercase m or a makefile with the uppercase m. To see how it works, imagine you have a pair of source files that together create the launch program. Okay, so let's see, pair of source files. Is it a pair? Oh, it is a pair because header and the C files, okay, which then makes the object files, and then we finally get the launch. Okay, the launch program is made by linking the launch.o and thruster.o files. Those files are compiled from their matching C and header files. But the launch.o file also depends on the thruster.h file because it contains code that will need to call a function in the thruster code. Okay? So this is how we describe that build in a makefile. So this is the target. You specify the target, colon, all the dependencies, and then the recipe, the command. Looks like it's tab spaced. So 3 rules, okay? Tab character right there. You see the recipes must begin with a tab character. Must begin with a tab character. If you try to indent the recipe lines with spaces, the build won't work. Okay, sure. So to make thruster.o, we need thruster.h and thruster.c. Then we compile using gcc-c thruster.c, and then to make launch, we need launch.o and thruster.o. Okay. So then if we say make launch, basically make launch is going to run this one here, which will then, I guess, try to build launch.o first. Taking these dependencies and then generating this, then thruster.o, which will take this here and build with this, and then finally run this command here. So it's like kind of recursive, I guess. So every single object file it has right here will look for the target in some previous definition here and build if necessary. Okay. You can see that Make was able to work out the sequence of commands required to create the launch program. But what happens if you make a change to the thruster.c file and then run Make again? Okay, so it looks like it's skipped having to rebuild it looks like launch.c instead. So skip that because we only modified thruster.c. Okay? Make is able to skip creating a new version of launch.o. Instead, it just compiles thruster.o and relinks the program. Cool. Alright, there are no dumb questions. Is make just like ant? I don't know what ant is. It's probably better to say that build tools like ant and rake, wow, so many different things, are like make. Make was one of the earliest tools used to automatically build programs from source code. So this seems like a lot of work just to compile source code. Is it really that useful? Yes, Make is amazingly useful. For small projects, Make might not appear to save you all that much time, but once you have more than a handful of files, compiling and linking code together can become very painful. So Make will take away that pain and automate it. If I write a makefile for a Windows machine, will it work on a Mac or a Linux machine? Because makefiles calls commands in the underlying operating system, sometimes makefiles don't work on different operating systems. Can I use make for things other than compiling code? Yes, make is most commonly used to compile code, but it can also be used as a command line installer or a source control tool. In fact, you can use make for almost any task you can perform on the command line. It's kind of like a bash, I guess. Huh, cool. AutoConf is a tool used to generate makefiles. Cool. C programmers often create tools to automate the creation of software. An increasing number of them are available on the GNU website. Cool. Uh, let's try this exercise. Yeah, let's do this. So we're supposed to answer. So we're supposed to fill these in. OGG swing. Okay. So OGG swing most likely needs I guess OGG swing.c and OGG swing.h. And then what else do we need? So we just GCC these two maybe to get OGG swing, and I think we don't need the what is it? We don't need. Do we need the options to generate the object? No, because we want to get the executable directly, or is it just the object? Because this seems like this one seems like the program itself. So let's see what swing.ogg does. So swing.ogg, this converts white nerdy. Wait, is this compile? This is alright. Let's read the direction. Hey baby, if you don't groove to the latest tunes, then you'll love the program the guys in the Head First Lounge just wrote. OGG Swing is a program that reads an OGG file and creates a swing version. Yes, so you can complete the makefile that compiles OGG Swing and then uses it to convert the OGG file. Oh, okay. So to make this OGG Swing OGG, you need the white nerdy OGG file. So it's like it's not necessarily always compiling. Like we want to be able to run commands too. So to make the swing OGG, you need OGG swing. You need white nerdy.ogg. So these are two of the dependencies, and then you can run it this way to generate swing.ogg down here. And to make this OGG swing program, I think you just need to compile it here and just have the dependencies be the OGG swing.c file and maybe the OGG swing.h. So let's see. Yeah, exactly. So OGG swing.c, OGG swing.h, and then just this command right here, this GCC command, and then for swing.ogg, you just need the two files of the original song, the program we just compiled up here, and then the command to run to converge. Okay. Anyway, yeah. So if you have a very slow build, Make will really speed things up. Most developers are so used to building their code with Make that they even use it for small programs. Make is like having a really careful developer sitting alongside you. If you have a really large amount of code, Make will always take care to build just the code you need at the time you need it. And sometimes getting things done in time is important. Okay. Oh, yeah, we got another chapter done. And then we can also like I'm gonna skip this lab. I kind of read this one already. It needs an Arduino. And I don't think we're gonna learn anything specifically. I guess. I mean, it's just it's just Arduino stuff. I don't have one, and I don't wanna influence anybody to buy one if they don't want to. So, um, before we go to a new chapter, let's kind of update our webby project to kind of use header files and like source files, and probably create like a makefile and see if we can compile it. I think we know enough to do that now, so let's give it a shot. Um, yeah, so let's close all, and then let's go back to our webby project. I think we called it project 1. Yeah, project 1. And I'm going to rename this project. Now we have a name for our project. I'm not going to call it project 1 anymore. I'm going to call it webby. So webby is our new project. And I want to also delete some things, like just the webby executable, and we just have a main.c. And notice how like, and I'll just maximize this. Notice how we have, okay, notice how we have a lot of code here. I wonder if we can break some of this stuff out into a function. So for sure here, like let's break them out into functions first and then see what we can separate. So for sure here, right, we're going to need to parse all this out. But notice how we're parsing or we're doing things separately. For example, doing the CSS as one thing, and then doing the where is it? The contents as another thing. And I think that's like a good start is to separate these two things out into their own functions, like kind of like make styles and make contents or something like that, like the function names themselves, or uh, yeah, like write styles, maybe write styles and write contents. So, oops, let's take a look at here where we create styles. What do we need here? If we just look at this, well, we need the file pointer for the output file as a parameter, one of the parameters. We also need the style sheet file name as a second parameter. And then we could just create the buffer locally. And then we also need, I guess, the style file will just be created locally. That's about it, right? So we can just move all that. So we just yanked, oops. So we just yanked this, just for now. And then we create something called, let's do a void. Void write styles. Then we can just paste our stuff here. And notice how we're missing arguments, right? So we need output file because that's a pointer. So we could do file, um, output file. So that's one. And then we also need the page style sheet file name, which is also a pointer to a character. That was our file name. We just pass that in. And so we can write our, since we're passing a pointer, this will be the same reference as the output file from the other function, the main function. So that's fine. We'll modify it in place because we're passing an address, and then our file will get modified that way. And we just need to reference the pointer to the character pointer here as a string. So it reads in, and then we're just gonna basically use fscanf to get the string, and then just kind of write it to our output file that we're going to pass. So then what we can do is, given this block of code here, we don't need that anymore, but we need to just call write styles, and we'll just give it the output file and the page style sheet file name. And we'll do the same thing here for the contents. Yeah, so same thing. So we're gonna go up here, and we're gonna do void write contents. And we'll again give it output file. I'm guessing that's what we need. And what else do we need? So we have output file, and then we also will get the contents file anyway and create that file pointer inside our function, so we don't need the contents file as an argument. But we do need page contents file name. So let's actually add that to our parameter list. Okay, and then we'll just copy and paste all that stuff somewhere here. So declare line buffer. Okay, we create the contents file, we scan, we close, and I think we just need this. So just yank that, and then let's go back up to the top of the file, and then paste that in. Okay, and it should be fine. Yeah, we don't get screamed at or yelled at. Then let's replace down at the bottom a call to the function instead. So replacing all the contents here. Here, we'll delete that. We'll insert a line at top, and then we'll do write contents, and then we'll have output file, and then the page contents file. Cool. So now what we want to do is just try to see the program still works, right? Because we just moved code around, and we want to test it. So let's go back up to webby, and then we can do gcc webby or main.c, and then we'll get webby, or actually a.out. So let's change that. Main.c output webby. Now we get webby. And then we can execute our sample command. So path to CSS will be, I guess, home. What is it? Code. Average dev. I wonder if I could just do a current directory. Let's just do that. Style.css. And then -t will be my portfolio. And then the heading will be Roger's portfolio. Then contents will be contents.txt. Let's see. Let's do the current directory. And then finally, output would be current directory index.html. Let's do that. Okay, that generated something. We do open.index.html. Does that do anything? Yeah. Cool. So, got stuff. And so everything is still working. And we should probably close all this old stuff. So, we do have, I guess, a more separated, cleaner program. Now I want to turn all this into, like, I want to be able to turn these into header files, right? So I can probably do something like um, maybe uh, write styles.h and then write styles.c. Oops. Okay. And then what I can do here is if I go to here, I can actually take this line, right? And then I can copy that. I can paste that here to be the signature, the declaration. I can remove, I guess I could remove this last one. Oops. I can remove this last character here. And then that should be okay. But I need to also include, was it stdio.h? Because I think that's what it needs for the file. Yeah, for the file pointer. I think this requires stdio.h, so we'll do that. And then write styles should have the implementation. So going into write styles, I need to first include write styles.h. Remember with the quotes because it's local. We want it to search locally. And then we can just kind of copy and paste all this stuff here. Back up to here. Oops. And then that should be okay. And we can remove this. And then we should be getting squigglies down here because I can't find right styles, but not sure why. I think it's because of this thing here blocking it. But let's just include write styles.h, and then down here we should be able to call it just fine at that point. So let's see if we have the right structure. So we could do something like gcc dash or yeah, let's just compile the entire program first. So we do gcc was it write styles.h, write styles.c, and I think it'll automatically figure out, like using the main function, what executable generate. So main.c, and then we'll output that to webby. Okay, that works. So then we run our program again. Actually, let me do this. rm index.html. Run the program again. Open index.html. Cool. So we're good. Still works. Now, what we can do here is do the same thing for contents. So we'll have something called write contents.h. Then we'll have a write contents.c. And we'll just do the same thing as we did with our write styles. So we'll just copy this, paste it into our write contents.h, and then we can just include stdio.h because I think it needs the file pointer or it needs to be aware. And then also let's delete that, and then should be okay. Now we need to copy the contents here because we need a definition. So yank that, come here, paste, and then we have to include write contents.h, and we'll also, okay, so this is not screaming at us because implicitly I think inside write contents.h we're including stdio anyway, so I think that's why it's not screaming at us. So now we include write contents.h to get the function declaration. And then we can just remove all of this. Okay. And now write contents exists. So this should be okay. And then let me just delete these two HTML files so that we can compile again. and test. So, oops. GCC write styles.h, write styles.c, main.c, but we also need write contents.h. Let's see what happens if we actually don't do that. Let's see if we did this. Ha! Yeah, see, we need, it says undefined reference, write contents. So we do need to specify it. Write contents.h, write contents.c, then we compile. Oh, we have a semicolon. Let's fix that. So in write contents.c, we'll have to go back there and fix that. Right there. Okay, let's do it again. Great. And then we run our command again and test. Okay, looks good. All good. Okay, now we're not done yet. We still have another step. Just delete that again. And then it should probably just get rid of this a.out. I don't know why I'm keeping it around. Okay. Okay. Let's create a makefile. Yeah, let's do that. Okay. So let's make a makefile. It says we can just call it makefile with lowercase m. And the format is basically our target. So we want to make, was it write contents.o or write styles.o. And then what are the dependencies? We need write styles.h and write styles.c. And the command with a tab is to do gcc -c write styles.h write styles.c. And then we can have write style or write contents.o, write contents.h, write contents.c. Uh-oh, what happened? Is that Visual Studio autofilling? Let's do it again. Write styles. I need to get a better bin thingy. It's just write styles.o. So we have write styles.h, write styles.c. And then our command is gcc-c, write styles.h, write styles.c, and write contents.o, write contents.h, write contents.c. Why does it get to do that? Oh, because that pops up. Okay. Okay, so now we have gcc-c, write styles.h, write styles dot oops, not styles, contents.h, write contents.c. So yeah, that dash c creates the it creates the object file, right? The .o files. Anyway, now we want to make webby the executable. So we need write styles. Well, webby main. Let's do main. Right? Main.o. We still need main, right? So we have main.c. And then do we need, what else do we need? We also need write contents.c. And then write styles.c. And then write, do we need that? I wonder. Actually, let's do this. This. I'm curious. Do we need the dependencies? We can just do. Can we do this and then link it afterwards? Let's see. Wonder. Okay. Experiment. So we want to make the webby executable. So we need write styles.o, write contents.o, and then main.o, and then it's just as simple as gcc write styles.o, write contents.o, main.o, and remember -o comes after your list of object files. We'll call it webby. I wonder if this is gonna work. I'm not sure about this one, but let's find out. Let's run it, and then get an error. That means we do need to include our C files. So let's see. So if we have our make file in the same directory, do we just need to do make webby? Oh, that actually worked. Oh wait. Let's rm star.o. Let's rm webby. Okay. Okay, we're clean. We should probably rm star.gch too. Okay. Okay. If I just did make webby, oh, that looks like it worked. We just automated it, and we have webby. Okay. Now let's run it. Let's see. That also worked too. Let's see, do we have our index.html? Ah, right here. Oh wow, that's amazing. Oh, that was so worth it. Because we were running multiple commands just to make it work. But we have a makefile. That's cool. It's awesome. So this is going to help us compile faster now. We just need to do make webby. Just need to do make webby, and everything's made, and nothing changed. So it's telling us that webby is up to date. That's pretty cool. All right, so yeah, let's just commit all this and then let's call it a day. I think we learned a lot. Oh, we should probably do that too. There we go. Webby. Cool. Okay. See you guys tomorrow.